To go a little bit harder, let's take a look at silicon tetrachloride. So to write the formula for that, we need to look at our naming conventions for covalent compounds. From the word silicon, we know that we have one atom of silicon, and tetrachloride tells us that we have 4 chlorine atoms in our compound. To find the total number of valence electrons for each atom, we know that from silicon, with our one atom, we have 4 valence electrons because it is in group 4A. Chlorine, on the other hand, we have 4 of those atoms, and it's in group 7A with the rest of the halogens, so it has 7 valence electrons. This gives us a total of 4 valence electrons from silicon, 28 valence electrons from chlorine, for a grand total of 32 valence electrons in this structure. To get started with the structure, we need to put the most electron-deficient atom into the center. Chlorine needs to gain 1 electron, whereas silicon needs to gain 4, which means that silicon is the most deficient atom and is going to go into the middle of the structure. To get started with drawing the structure and putting in the electrons, we're going to connect each of those chlorines back to the central atom with a single covalent bond, which is a pair of shared electrons. To make those bonds, we needed to use 8 of our valence electrons, which brings us down to 24 remaining. From those 24 electrons, we're going to start satisfying the octets of the chlorines. So 1, 2, 3, 4, 5, 6 are used to fill the octet of that chlorine. At this point, it is full. The next chlorine can have another 6, 3, 4, 5, 6. Brings us down to 12. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. At this point, we are out of valence electrons. We need to make sure that all the octets are satisfied for the chlorine atoms around the outside. And in addition to that, we need to make sure that the octet of our silicon in the center is also satisfied, which in this case it is. We can redraw this using a single line to represent a single covalent bond between the silicon and the 4 chlorines. And then we are going to make sure that we keep all of the non-bonding electrons still in our drawings that are around the outside of our chlorine.